Hi students, we are going to look at the last part of electrolysis, which are the applications of electrolysis. So electrolysis is a widely used industrial processes. Okay, one such use is to purify metals such as copper. So metals such as copper, naturally occurring because they are reactive, they don't usually exist as pure metals. Okay, so they will react with the oxygen to form oxide, the nitrogen to form nitride, sulfur from the environment to form sulfide. So they exist as what we call ores, O-R-E. Okay, so remember the anode, when I have a reactive electrode, the anode will dissolve. Same thing, the oxidation process is still at the anode because an ox. Okay, and then oxidation is losing electrons. Okay, so the anode will dissolve, and this anode will be fixed with the impure copper. Okay, and the cathode will fix with the pure copper. Okay, so the electrolyte will usually be something that contains your copper ions. Okay, so the cathode, same thing, let's write this down. At the cathode will, reduction will occur. Okay, and the cations attracted. And reduction is gaining electrons. Okay, so using a picture, let's look at it, right? So same thing, your battery is the short end. This is the negative. So this one is the negative. It is going to attract the cation. So this is the cathode. So that's where you have 100% pure copper. Okay, and then we have the impure copper at the anode on the other side. Okay, so likewise, what's going to happen is your anode will dissolve because it is a reactive electrode. So your anode will dissolve. So what is really happening is the pure parts of the copper from the impure copper, so only your copper ions will get oxidized. Okay, so what is really happening here is only the pure parts. Copper metal piece, right, it will dissolve to form copper 2 ions. Right, so thinking on the right side, if you gain electrons, this part you are losing electrons. And when you lose the electrons, it is oxidation. Okay, so the pure copper will go into the solution, Cu2 plus, and then whatever that's impure will fall down as what we call sludge, or just the impurities. Okay, the Cu2 plus, there will be a solution from your electrolyte that contains Cu2 plus as well. And all this Cu2 plus the H plus that's inside will migrate to the cathode. Okay, and then your copper ultimately gets preferentially discharged because it's lower in the electrochemical series. It is more easy to lose the electrons, or sorry, it's more easy to gain the electrons, right? So my Cu2 plus will actually form or gain electrons over the H plus, all right? And it will get preferentially discharged to form copper. And that's where you see your cathode gets bigger and bigger. You have more and more pure copper. So that's how we purify metals. Okay, another process that we use is called electroplating. So in the industries, yeah. Okay, so this process coats a metal onto another metal object in order to beautify it. Okay, so it could be gold plating, silver plating, copper plating, etc. Okay, the anode is fixed with the plating metal, while the cathode is fixed with the object to be plated. Okay, so remember, when your electrodes are reactive, the anode will dissolve. Right? So this is the metal to be plated around object. Okay, so in fact, if I put a pure silver here, means I want to plate the object with silver. And because your anode will dissolve, my Ag will dissolve to form Ag plus electrons. Okay, so this is losing electrons, right? Oxidation is lose, oxidation takes place at the anode. Okay, so this part is your anode. This is the positive plate because your anions get attracted. Okay, and the object to be plated will be the negative plate. This is your cathode. So let's look at the ions that's inside again. Because you have silver nitrate solution, you have the silver that comes from the electrode, the silver that's already inside the solution, the electrolyte, and the H+. Right, so which one do we circle? We circle the silver ions because it is lower in the electrochemical series. Okay, so what's going to happen? It is easier for your silver ions to gain electrons to form silver. Right, and then when it gains electrons, it is easier to be reduced. And red cap, so it occurs at the cathode. So your silver that is formed coats around this object. So for example, if this is a spoon, then you will have a silver plated spoon. Okay, common uses of electroplating. These are concepts that will appear in your MCQ. Okay, chromium, this one is used to plate water taps, motor cars, bicycle parts like your handles and all that. Okay, tin is used in your tin cans. So for example, the fruit cans like your longan can, rambutan can. Okay, silver, this one is to use for trophies, plugs, knives, and fork. Okay, so these common examples is memory work. This one will come out in the MCQ. Okay, so rules of predicting selective discharge. Okay, we have inert electrodes, yeah? Identify the cations and anions in the electrolyte. And aqueous, I will have H+ and OH- from the dissociation of water. Okay, at the anode, oxygen is always produced because your hydroxide ions will form H2O plus O2. Balance out your equation, you need 4 and 4 electrons. Okay, this is the thing that will always happen at the anode. Okay, anions get attracted to the anode. Unless, what will happen? Unless the group 7, the chloride, bromide, iodides are in greater concentration. Okay, so if when your concentration increase, then the discharge will be, the group 7 will be preferentially discharged. And you will get your chlorine gas, bromine liquid, iodine gas. Okay, at the cathode, reactive metals such as K+ and Na+ are never being produced. Okay, especially if you are using aqueous, they are never produced. But if you are using molten, then because there's no selective ions to discharge, right? So they will be produced if you are using molten. Okay, most of the time you will liberate hydrogen gas because hydrogen is very low in your reactivity series. What are the things that will get deposited only if they are below hydrogen? So usually it's my copper, silver, gold. Okay, identify the cations and anions that remain in the electrolysis. So usually I will circle what is being discharged and cross them out. So look at it and you'll see what are the ions that are left in the electrolyte. So they are the products of the solution. And last but not least, if you have a reactive electrode, you must know the anode dissolves. That's the oxidation reaction. Okay, the anode will always dissolve when you have a reactive electrode. Okay, that's all for your electrolysis.